Okay, this is IM1 and this is lesson 5-4 about exponential growth and decay. So we're going to start with the key concept. The key concept here is that exponential growth can be modeled with the function a times b to the x. A here is the initial amount, and b, which is what we're going to call the base, is the growth factor. And the growth factor has to be greater than 1. So that's an important thing to keep in mind. It has to be greater than 1. The initial amount also has to be greater than 0, so it has to be a positive number, but it could be 1. You can start with 1 of something. We're going to look at some problems to explain what we mean by the growth factor greater than 1, but just keep that in mind whenever we think of it's growing by 75%, you're going to need to think of it as a number bigger than 1. Okay, I turned the page here. We're going to do practice 1 first. The college enrollment of students enrolled at the college is 15,000, and it grows by 4% each year. Okay, so the initial amount, A, remember our equation is going to be A times B to the X. The initial amount A is the starting, that's 15,000. The percent or the rate of change is 4%. So the growth factor is 1 plus 0.4. So that's going to be 1.04. That's what it's going to look like to make a number that's growing 4% but growing, because you're going to have 1, which is the initial amount, and then a 4% growth. So to calculate each number of students, we're going to times it 15,000 times 1.04 to the power of x, right? So after 1 year, that's just going to be 1, so it's going to be multiplied by that. So we're going to complete the equation. So the equation is going to be y equals 15,000 times 1.04x. So what does that even look like? So if we did that on the calculator, it's going to be 15,000 times 1.04 and the power of x. Let's say we wanted to know what it's going to be after 5 years. So after 5 years, they're going to have 18,249 students. You can't have a decimal of students, even though the math will give it to us. All right, so question E says use your equation to predict the number of students enrolled after 25 years. So that's going to be y equals 15,000 times 1.04 to the 25th. All right, so let's do that math. 15,000 times 1.04. In my calculator, it's this button. It might be different in your calculator, to the power of 25. All right? So at that point, it's going to be 39987. And we'll leave it off the decimal because you can't have half a student. So it will have grown to almost 40,000 students. All right, let's go up to the top and do problem 1 with got it. Suppose that in 1985, there were 287 cell phone subscribers in a small town. I don't believe that at all, but whatever. The number of subscribers increased by 75% each year after 1985. How many cell phone subscribers were there in 1994? So what's our starting number? So again, it's y equals a times bx. So our starting number A is going to be 285. We're going to multiply that by, our growth is 75%, so 1.75 to the power of x. There are 9 years between 1985 and 1994. So we can figure that out by saying 285 times 1.75 to the power of 9. And again, I'll just do that on my calculator. It's pretty straightforward to be able to do. If you don't have a calculator at home, you should be able to do it on Desmos. To the power of 25, or excuse me, to the power of 9. All right, so then at the end, there were 4, 3, 8, 7. This is so close, we'll round it to 2. There were 43,872 subscribers.